So I'm gonna keep on looking up here. I'm gonna try and stop. So I'm Joel. There's the topic. There's the slides. All that fun stuff. I just flew in from Chicago, and boy, are my arms tired. All right, it's about as good as it's gonna get. So just kind of a heads up. Was anybody here for Yvette's presentation about right before this one? Yeah, yeah. Mine's just gonna have worse jokes. It's gonna be a lot of overlap, but we'll get into it. So the slides are up there. A little bit about me. I wrote a couple books. You can kind of see them on the side. Typically, I help organizations build better products by actually learning how to build better products. In today's economy, that's not too popular. Turns out they don't want to learn. They just want to ship stuff. And then I got a book coming out next year with IT Revolution talking about systems designs and all this other kind of fun stuff. So that's the one side of the slide. The other side is like all the places I kind of been, some of them, right? One that's not shown is actually a company, so I'm, as I mentioned, from Chicago. One company that's not shown on there is the company I worked at in the early 2000s, the CME Group. I don't know what they go by now. Anybody work there, have friends there? Good, it's a horrible company, so if you have friends, have them quit. The reason why I mentioned CME not to have you quit there is that was probably like my first modernization that I tried to do. It was 2000, 2001. I was a great, young, smart whippersnapper. I said, I know we just merged with another company. While we're doing that, I'm going to modernize everything. And if you don't know anything about CME Group, they provide market information for traders. Turns out, if you bring down production for traders, they get pretty upset, right? And so that was a big thing that I learned was don't bring down production while you're trying to modernize stuff and merge companies and all this other stuff. So that's where I started, bringing down prod, and I'll take you through some stories along the way around how not to do what I did. All right, so to first get into it, we'll talk about if we're gonna modernize our tech, why are we actually modernizing? This is some of the stuff that Yvette was actually talking about. When I think about modernizing tech, is anybody going through like a tech modernization now? Yeah? And who's doing it because they have old technology? Yeah, that's a fun one. Anybody doing it because you have to go to the cloud and therefore you gotta modernize? Yeah, a little bit. Yeah, yeah. Or you just might have like you might have an old interface or an old product. Anybody have an old product that just looks bad? Yeah. All great reasons to modernize, right? Because like the tech's old and we don't know what's going on. Or it's like, you know, it looks ugly, so we got to make it look better, right? All that kind of fun stuff. When I think about, those are great reasons. I think there's a lot of other reasons that you might want to consider modernizing your tech stack. The biggest reasons for me, and you'll see this come up a little bit throughout the deck here, is for me, I've been with some organizations and been helping groups where it's like the architecture had an idea, and we designed it based upon how we thought the product should work 10 or 15 or 20 years ago. And then what happened is the product changed, right? And it turns out the architecture and the product are no longer aligned. That's a problem. Sometimes what happens is as the product grows and changes, what the product needs to have happen doesn't really line up with the code. So it's not just architectural and separation of components, but it's like the words we use in the code don't match the words that the product actually uses, right? And so like now we have this kind of disconnect. And then I see the product and the organization are no longer aligned. Like the way the teams work is no longer the same, which makes it then hard for the product to ship. And so you see all these kinds of problems. And it's all really just, I think, good ideas to modernize. Now, when you have these types of problems where it's not just an ugly UX or you're going to the cloud or old technology, and you have these kind of like organizational kind of problems, you tend to see these other kinds of patterns where you have high cost of delivery. I don't know how Europe is, but like in Chicago and in America, we like to solve problems with meetings, right? So like the architecture's bad, so let's have more meetings. Let's not fix the architecture, let's just have more meetings because if we plan better, then therefore the architecture will miraculously be better. Here's a kind of heads up, meetings have never solved architecture problems, right? You actually gotta fix stuff. So you have high cost of delivery, you get lower innovation, you get people aren't learning new things, people get upset. So I think there's great reasons to modernize that aren't just go into the cloud, need to be microservices or something else. Look for these other kind of signals as well. So for me, modernization is about this kind of idea about enabling better product experiences for effective product delivery by rethinking our tech. That's kind of what it's about for me. So far, so good? All right. So here's the techniques we'll go through. I'm going to give you examples along the way. I'm going to go under the assumption that you actually want to do some modernization. We'll talk about realigning product and architecture, talk about finding seams. I mean, you can kind of read it up there, right? Questioning assumptions, kind of figuring out your product along the way. One thing that I love that Yvette said, and that we'll come back to at the end, is I think in our industry, we have a horrible misconception that when we're talking about modernization, it's either an A or B problem. Either we modernize and don't ship, or we don't modernize and continue to ship. I've had this conversation in a lot of organizations, and there's a whole lot of good options in the middle, and that's kind of the essence of this talk, is like, how do you do those things in the middle where it's not just like stop building software, you actually iterate and do things progressively. I'll give you some stories along the way. The one key story I'm going to share with you is for a current group that I was with. They've been building a product, successful product, going on 20 years. Started off as one team, they got things done, and then they needed to get more done, so they had a second team. And then they needed to get more done, and they weren't going fast enough until they had 14 teams working on one product, not really shipping anything. Kind of expensive, but that's how we do things in software. It was over 1.4 million lines of code, right? So it was not a small code base. It was struts and JSPs. It had EJBs. Anybody from the Java world remember EJBs? Yeah. You know what's fun is when you go work with a team of developers and they're supporting EJBs, but they don't know what it means. That's when you know you might want to think about modernizing your tech. It was also running on WebLogic. Anybody here from Oracle? Good, because I think the dude that owns Oracle, if he owns an island, you probably don't need to give him more money, right? And so the company also was paying millions upon millions of dollars to Oracle for WebLogic. They had motivation, therefore, to get off WebLogic. It was also running on DB2, right? So just kind of old, gnarly technology that I'm going to share with you about how we started, without bringing down production, moving stuff off of it and saving millions of dollars and having a better time. So the first thing, realigning the product and the architecture. This is an oversimplified view of their architecture. You got that fancy person at the top, the stick figure, saying, "I just want to do something. Look, I have so many ways I can do it, right? I can go through Salesforce and do it, or I can go through a mainframe and a green screen and I can do it, or I can go through this web app and do it." Now, it's good to give customers choices, right? That's a good thing. But when you give them so many choices that all that happens is all of your data integrity in the back end's out the window, you're going to have a bad time, right? And so they had this kind of going on the front end. It was one big, huge deployment. There were, lots of teams kind of sitting on here. Everybody intermingled. Everybody was dependent upon each other, right? Nobody having a good time. Eventually, it got to the database, and everybody could read and everybody could write, because that's democracy, right? Everybody gets free reign to the database. Does that sound like anybody's organization? A little bit? You mean, if you're embarrassed, I get it, but it's a problem, right? And so, like, from a pure product perspective, you can imagine it was hard to get things out, because any change in one area affected everybody, right? And then if you actually had an issue in production, you're trying to figure out where it came from. It could have came from anywhere. And so, like, it was just really super hard to figure anything out. The problem here was a misalignment with the product and the architecture and the teams. This is I do a lot of causal models usually in other talks, but for me, like, I look at, as architecture disconnects from product, you start to get these signals. The increase in cognitive load. What I mean by that is, for any of those 14 teams that was trying to deliver a new piece of functionality for the product, they had to know about every other team. And they had to know about all of the possible states, because all of the code was coupled together so nasty, right? And so for me, cognitive load wasn't like it was hard. It was, I have to know too many things at one time, and I can't possibly process all the permutations. in one example for one team that I was working with, they had 900-line if-else statements. How do you reason a 900-line if-else statement? You don't. And so you put a code in and guess, and you hope it doesn't break until a month later it broke and you don't know why. And so like cognitive load for me is like we had to think about too much. It wasn't that thinking was bad, it was that we had to think about things we shouldn't be thinking about because of this bad coupling. For me, in lots of organizations, another signal that the architecture is separated from the product is that it's hard to test. We can't test anything unless everything works together. For me, that's a sign that like we got this kind of artificial coupling, the architecture's kind of outgrown its needs, and now we can't test independent ideas. So I look at testability as a signal that the architecture is separating from the product. This, of course, affects environment stability, right? If you can't test well, you get weak environments. And as, of course, as I mentioned, for some reason, increase in meetings to solve these problems, which doesn't solve any problems. Again, for this organization, it did not happen overnight, right? This was like a slow bleed. It was way more than just technical debt. It's easy to say the code was bad, right? But it also affected the decisions the organization started making. By that, so in America, we make a lot of bad decisions. Recent history shows that to be true. In particular with this organization, because they had 14 teams that couldn't ship fast enough, the decision was made, all of the bug fixes, we'll just outsource those to somebody else, right? Because that way we can work on making more features, right? And so I guess it made sense to somebody, but then what happens is you get all these integration merge conflicts, and then you have the outsourced bug fixes that don't know why the code was here in the first place, and it's just a mess anyway because you can't test it. And so, again, this caused a lot of friction, right? And so fundamentally it was about realigning architecture and product. How did we do it? There you go. Any questions? All right. I know it's super hard to read. Some of it intentionally. In the upper, that corner, so upper, I guess right, left, that one, before we started doing anything, we actually got together, did some event storming, right, kind of looked at how the product should exist and where context changed across teams. The idea being kind of separating out cognitive load, right? So the first thing we tried to do was not even talking about, is this microservices, is this cloud-based? It was just fundamentally, from a product perspective, how does the product work? What's the experience like? When does the meaning of the product change? So if the meaning of the product changed, then we need to almost have like a different domain, different context for teams, right? And so we started off with this, getting product owners and architects together and just talking about how the product should work, looking for contextual shifts. We use that as a kind of like the Eric Evans DDD whirlpool way of looking for bounded context, and then did little code probes with teams to see how it would work. We started separating out teams this way. The bottom, I'm sorry, that side, where you see the kind of separation of concerns in teams, is once we had some ideas of bounded context, we deferred decisions to we deferred architectural decisions to the teams that were responsible for a context. And so what that means is some teams could choose if they were going to be API driven, if they were going to be event driven. You know, they could have some loose decisions around how they best served their part of the product. What's interesting about those first two is the product itself wants to be innovative and creative in different domains at different times. So for example, with this company, the furthest this way was just around, I'll give you kind of some of the extra information. It's a financial company, and the idea is that they want your money, of course, right? And with the promise that they'll make you more money, right? That's how all financial companies work. That's the mystery. And so on the furthest side was just around how do we get more people to like sign up to our newsletters so eventually they can become customers? Well, that's not very exciting. That's kind of static. It's kind of flat, right? So that's easy. We can be creative, but it's not that interesting. As you get further on into the flow, where you get into like, how do we, like, what money can we take in? Okay, well, if we want to go international, we have to accept different currencies and different banks. And then you had different, and as you kept going, and you got into the trading side, then you had different strategies and different ways of trading. And so, like, you wanted more flexibility in certain areas than other areas. So again, we're trying to align the product needs with the architecture, then the architecture can become more dynamic based upon the needs of the product. So kind of balancing those things out. So that's how we got to the diagram over there, where it was kind of like loose teams, and they would start designing their own architecture in their context. The bottom one over here was us talking through, at a high level, if we have these contexts in these teams have their own kind of architecture, and this is how they're solving their context. What is that interplay across teams going to look like? Because again, this is a large organization. The thing that I want to stress about this, I'm not here to badmouth any SAFe framework, for example. But for example, SAFe. If you think that every 3 months everybody in the whole organization needs to get together to talk about everything, it doesn't sound like a good use of time. And so what we were doing was, we were trying to figure out appropriate communication patterns across teams. So if a team could exist just by having a shared contract, that would be good. If the contract was going to change, then they should talk, right? And so we were talking about types of strategies there. What was interesting is, in this middle here, you'll see a large circle with 2 circles inside of it. There was a necessary coupling across teams. A necessary coupling. It was around where the money was and how we traded it. Because it turns out, when you trade, you need to have money. And when people want their money from a trade, it's got to be pretty coupled. And so it's got to be fast, and so you have to have good communication around how you want to handle that translation. What was interesting about us doing it this way was, we found this necessary coupling, and that doesn't mean prioritize my JIRA tickets in your backlog higher. It means we actually should work together, right? Like in software, we talk about collaboration all the time. Collaboration means we work together. It doesn't mean I get together and I stand up and say, ticket 1274, no blockers, and then I ignore you as you talk about everything else. Collaboration is us working together. So again, what we did, got together, talked about the product from a context perspective, looked for team boundaries, gave teams individual responsibilities for like how they want to solve, and then looked at necessary communication patterns to talk about where we should work together and where we shouldn't. So this is how we started realigning the product with the architecture. Now, this might sound hard to believe also, but putting virtual stickies on a whiteboard does not fix any problems. You actually have to do some work. So then we started getting into the code and said, okay, we have this idea of where we want to be. How do we actually start iterating towards this product, or is it architecture? We looked at this idea of finding seams, right? So if anybody's read Michael Feather's book, Refactoring Legacy Code Bases, he talks about seams and talks about seams as seam in code is an inflection point, right, where you can divert. We were looking for like seams in the product, right? So like really simple seams in the product where you can either experiment or segment out and say, this group is going to get a new experience, but we still have a fallback. Now, what we did for this financial group is you could create like 145 different account types for some reason. I don't know. And so what we said is, what's a logical segment that we could divert to a new experience? New experience, new architecture. And so we found one. It turned out it was like 20% of the traffic, and so it was kind of like, okay, we found a good inflection point. This is where we can kind of, inside the product, we can give them an option. Do you want to do the new route, the new experience, or do you want to stay with the old experience? And so it was just that simple. You got a button. And if you chose the new one, you went down a new route. And if you chose the old one, you went down the old route and crossed your fingers for the best. But we found this seam in the product that was a small market segment and said, we're going to divert this group over here based upon a product segment. This is not from that company. This is a different kind of example. But like the idea is still the same. If you had a shopping cart and you want to divert them based upon they're in this country and we're going to calculate sales tax or shipping a new way, you can do it like this. What we ended up doing was the old group got the EJBs, and the new group got the APIs. So again, we just kind of found out a simple seam in the product, created this one API that people could opt into, and if they use the one API, they got the expedited service, their product, their account was opened up. If they didn't, they went this old route. So legacy code base still running, new kind of microservice running on the side in parallel. In production, everybody's happy, right? So far, so good. Seams aren't always an option. I can give you, in one of the earlier slides when I had a bunch of companies up there, I did a bunch of work at Target, so the retailer in the United States. This was about 10 years ago, so this is kind of like that one of those progressive stories. About 10 years ago, they were trying to modernize their promotion platform. Now, they were modernizing their promotion platform at the same time Oprah Winfrey was going to mention it. Right? So, like, that's probably the wrong time to flip the switch and say, fingers crossed, this doesn't happen. What they did is they did the whole idea around parallel paths. So, like, the existing thing worked the way it did. So when you signed up for a promotion, it still worked the other way, the old way, and it also went the new way. Now, the new way didn't notify you the promotions, but at the end, we tracked the records and tracked the database and tracked the logs to see if the end result was the same as the old result. So we iteratively build up parallel paths until we are confident that we could do a cutover. And I think that's interesting because it was too big to cut over any other way. And so we kind of went with this parallel paths, diff, what's missing, what should we add until it's in a good spot. So I think, again, if you can't find a product seam, this idea of parallel paths is wonderful. So we found a place to kind of go in. We find a place to shim in some code. And now it gets into the fun spot, questioning your assumptions about your product as well as your code. If you're using something like SonarQube, right, you can go into it and say, show me my dead code, and you can remove it. The older your product is, the more bad ideas it has. Well, not just bad ideas, the more non-relevant ideas it has. And so when you're thinking about modernizing, if you're thinking, I have to do like for like, you're already kind of behind the 8 ball. Because you're probably modernizing things that don't even matter anymore. If you take out dead code, that's a nice start. That's just static analysis, though. More interesting is if you actually go through it and you can find code that it's actually never used while it's running in production. You can do any kind of AOP. I think there are some other libraries out there that will actually do runtime detection over like a week or a period of time that will say this code was never executed. Now, of course, if your product is seasonal, you might want to make sure you're in that season and not delete, the wrong code. And then, of course, the third option is for just looking for ways to make the UX better as you deliver. The reason why I bring this part up is when we were modernizing this financial client's product, there was like a checkbox, or I'm sorry, a table of all the documents you had to sign, right? And so a simple question is, why is there a checkbox next to some of them, not the other ones? And they go, well, that's because some of them are required and some of them aren't. Okay, that makes sense logically, but you have in the table that says, here's your required documents, some of them are unchecked. So now what does it mean? Oh, I don't know. And it turned out that it was just old code that no one ever questioned. And like before we used to show it in a checkbox, now we show it in a table, and now it's just confusing. And so then the question became, is there a better way to show that data in general? Right? And so like now we're starting to question things because we don't want to migrate like for like, we want to migrate better. We want to modernize to better. And so these are kind of things I'm looking at. I'm trying to figure out, yeah, we should get rid of dead code because it's not being used, it's not being executed. Here's bad ideas in the product, and here's ways we can actually simplify the code so it doesn't, so it's less confusing and less to migrate. Now, when we did this, for every engineer I've been with, for some reason, deleting code is scary, especially if the code is older sometimes than you, and then you're like, I have no idea what will happen if I delete this code. If you're not familiar with the Mikado method from Ola, I highly recommend that as a way of kind of finding the external pieces of code base that you can logically refactor or start to remove. I feel like I have to tell developers too frequently, you can revert, right? Like that's why you have version control, so you can recover, so you don't have to comment everything out. If you get nothing else out of our time together, take this as a tip. You can delete code, and you don't have to just comment it out, all right? And so what I'm trying to get here is when I'm trying to do modernization without bringing down production, I'm trying to find the code that I shouldn't even be worrying about, because otherwise it's just kind of noise. So I'm trying to do for different ways to look through it. As I'm going through the products, I'm asking questions, right? Is the idea still relevant? Do people use this? If you don't have any metrics around people using your product, I tend to get a little nervous, because then you got to do different techniques. But like, I'm trying to figure out how the product's being used. If you're in a part of the product that has a lot of data, I was with a healthcare provider that was kind of doing some of this modernization stuff, but probably in a bad way. And what was happening was they would show a table of data to like a nurse that was making a request for insurance approval. And so what was happening was they kept on getting all these requests in from nurses. This data's missing, I can't do this isn't there, this isn't there. The engineers just kept on adding more data. So the table got wider and wider and wider. Once we actually slowed down and said, like, is this data being used, we found out that, like, it turns out the data was available, it was just off the screen. And so nurses weren't even looking at it. So we kept on adding more and more information while we were trying to modernize, and we shouldn't have been. It came back to this kind of fundamental questioning, should we actually be doing this or not? So be thinking about those ideas, right? Now that we have an idea around like the architecture, we have an idea of where we're going to do it, we're trying to minimize our work that we're actually going to do, then we get into this idea of making boring changes. When I started working with some of these teams that was doing this modernization most recently in that financial group, smart developers, just like I'm sure you all are, they wanted to do a lot really fast. They had this EJB that would call a mainframe for 140 different types of accounts, and then they wanted to like make that an API right off the bat. I go, do you even know how to connect to the mainframe? And they said no. I go, how about we start small and try and figure out how do we connect to the mainframe and actually do something? And so I kept on talking to them and saying, like, we got to make this as boring as possible. And it wasn't boring for boring's sake, but like the question I would ask them is, are you scared to put this in production right now? And if you are, then it's not that boring, and we should probably find something a little bit smaller. We got to the point where things were so small that, like, again, we weren't changing the database. The first change we put into production, this is how it worked. You got that pop-up on the screen. Do you want the new flow or the old flow? If you click the new flow, it took a 4,000 character XML string from the old system, put it in a temporary column in a database, and called the mainframe job that was looking for that string. So like, again, we didn't touch the mainframe. All we did is kind of said, all of that data that you built up that we probably don't need, I'm just going to put it over here and let that thing call it. Because now I got my seam in, and this is like boring. Because even the engineers were like, of course it's going to work. Yeah, that's the point. We want that to be the continuous thing. Of course it's going to work. Of course, it's so boring, let's get it out there. So that was the thing we did. We didn't change the database. We didn't change the UX. We just kind of did this one thing over and over. And then we started kind of working from the inside outwards. That 4,000 character XML string, here's a horrible tidbit for you. A lot of it was hard-coded. Because it turns out a lot of it wasn't needed, but we didn't know. And so we just kind of hard-coded a bunch of it until we kind of figured out what was actually needed. So again, kind of boring stuff. We moved some stuff to in-memory databases. But what I would tell you is, like, learning isn't boring. We didn't know kind of like how anything worked. We didn't know how to call a mainframe. We didn't know what data was necessary. We didn't even know what data was actually being used. And so we had to start with all of these assumptions that we were wrong, kind of make things static. And so in this first diagram, you can see we kind of did this 10%, and we said they're going to call the API, but the API really is taking the string that's already built up and sending it to the database. It's going to be boring. But we're going to learn a little bit along the way. We're going to learn kind of like which fields need to change, because the DB2 would tell you like, hey, you violated a constraint. I think I lost myself in slides here. Yeah, so that's the API. Oh, then we put the link in on the UI, so you can kind of cut over to it, right? Then what we did is, we didn't even change anything. We just introduced messaging, because we knew architecturally that we wanted to go a loose couple event-driven system. And so now we had one team that was predominantly only taking 20% of traffic statically for one account type, very similar to how it used to work. And we were just publishing messages to Kafka that nobody was even listening to, because we knew eventually we needed to get there. But now what happens is now we have sample messages that other teams can start using to replay to make sure that they're building up state on their own. So we're introducing new technologies kind of as we went. That was fun. That kind of sussed some things out. Then we went to the next team. And now we still only have a product segment in place. A lot of it is still hard-coded. We're pumping things to Kafka. And now we said, could this one team, based upon what they're seeing from Kafka, introduce another seam on their side that they could then respond to. And so now, hopefully you kind of see this pattern emerge. It was take a product segment, find out the architecture, how we want to decouple things, figure out a product segment, find out the least amount of product we needed to move, segment it out, right? Kind of do a lot of it static, introduce a new technology, allow one team to start building up on it. So it's, again, still a small segment. Production's still running. And now we have something starting to run in parallel that's getting better and better. And we did this over and over and over again. We started adding teams, right? And we just kind of built it up along the way. The whole time, these teams are still building and shipping features on the existing legacy code base. Wasn't that fun, but we had to do it. When we could do it on the modern side, we of course did. My favorite example that started getting some headwinds, one team had to implement a feature on the legacy side because they weren't ready to kind of cut over yet. Took them 4 months, right? Took them 4 months to ship it. When they came by to do the modern side, it took them 2 days. Because it turns out, when code isn't so coupled together, it gets really easy and really boring. So just a nice kind of segue of saving time. So now we got some code running. We're doing things boring. What I had did with my team, and of course your experience may vary. I mentioned we did a lot of things statically. Static strings, static values, because some things weren't relevant, but they were needed for the mainframe. So we just kind of hard-coded some values in there. I was always telling the team, let's not try and be smarter today than we need to be, right? Because I think as engineers, we want to say, I can figure out the algorithm. Just give me 5 minutes, right? I can figure out the data structure. Just give me a couple minutes, and it'll be perfect for all of them. We fought that over and over again. Don't be smarter today than we need to be, because it's going to change anyway. And so, this picture, which is I should have zoomed in a lot closer, was from their additions and deletions from their repo. I think it's interesting because, like, you can see the green. Of course, when they first started, you have a little kind of peak, and then all of a sudden it shoots up a lot, but then the deletions shoot down a lot. And so what was happening was, like I said, we were hard coding things, doing very small, safe, easy to ship things that we were confident weren't going to break things. Then as the pattern started to emerge, we actually refactored, right? We actually did it. We actually deleted code. And so I think that's what's really cool is, by not trying to be smarter today than we need to be, as long as we are going to delete things when it's appropriate, then we're in a good spot. It was easier to delete things. It was safe because things were running in production, right? We understood how it worked. We had tests then. So like, we just let the code grow until the pattern was obvious. And I think that's a beautiful technique. This is how you don't get yourself in a spot worse now than you were in the past. As I mentioned, what we did, seam, hard code, kind of expand outwards, then refactor and come back. for me, that was you know, this stage is kind of hanging, right? I don't know if you know that or not. So like that was, heads up, this is hanging, right? Yeah. So like that was kind of freaky. Anyway, find a seam, kind of hard code some stuff in, let the code kind of grow naturally, have good tests, and then refactor and extract appropriately. We did all of this continuously, keeping production running, slowly, kind of getting more and more functionality, working on the modern side, and then getting the product in a better spot. In that first diagram where I was talking about aligning product with architecture, one of the things I didn't mention, Yvette did a nice comment also around making sure there's customer value when you're doing these types of modernizations. The company had a financial desire to modernize because of WebLogic and all these kind of licensing problems. The code was bad, right? All these kind of smells. From a product perspective, there was things that they were asking to do for 5 years that couldn't be done. And so like, we were also using that as a way to introduce the value of the modernization. So as we were introducing new product features, or as we were modernizing, we were introducing new product features. So like, it was never a question of the business won't let us do it. It was like the business is super excited about this. I want to be careful we don't create a false separation between business and IT. All right. For some reason, this question tends to come up: should we modernize or migrate? Should we modernize or rewrite? Should we refactor or rewrite? I think there's lots of good answers and a couple of real bad ones, right? For those, anybody in here read Don Reinertson's book, Principles of Product Development Flow? Yeah? All right. Well, if you haven't, you should. It's a really hard book, just as a heads up. At least it was really hard for me. I had to read it a few times. One topic that Reinertson talks about in there is the idea of U-curves. And so the whole idea being that, you know, for any decision, there's contributing factors, and usually the most wrong answers are at the extreme ends of the spectrum. That's kind of how I think about this question of should we modernize or migrate? Should we only do features or do a rewrite? I think what the question assumes that one of the extremes is right. So I don't think that's the case at all. When I was actually first working with this organization, I get their idea. I'm not going to say it's a good one. So the way they looked at it was either we do it now or we outsource it. The idea being, the fundamental thought they had was that the cost of this modernization effort is hourly, right? And so therefore, if we have 1.4 million lines of code and it takes X number of hours to do per lines of code, if you multiply that times a rate, you get a cost. If that's the case, then you want that cost to be as cheap as possible, because that's just math, right? If you multiply a rate times time, you get total cost. I actually, and this pains me, because like you all, I like to write code and build systems. I actually had to write a 15-page economic paper for this organization that says that is not the cost of modernization. If you look at it just hourly, yeah, you can look at it this way. Your team velocity is X, right? This is how much we ship. But what was interesting was that assumed that you had to ship all the code. Because what they were going to do was, again, they were going to take 1.4 million lines of code that nobody understood, because 900 line if-else clauses and a bunch of other horrible things. They were going to outsource it, not the outsourcing person's problem. You know, they didn't create the mess, they were just going to recreate it. The outsource company, who had no idea of the domain, was going to use AI to convert all the code. So that's another great idea, right? So somebody that doesn't know the product, use AI to convert the code, and then give it back to you to support it. What could possibly go wrong? Once we actually said, like, the total cost of this modernization and what does it mean, the rate was no longer the problem, right? when I actually laid out all the total costs, as you can kind of see up here, the labor house was different, but the total cost ended up being, what, I think $30 million cheaper to do it in-house. $30 million cheaper to do it in-house by doing it small piece by small piece, by kind of letting it naturally grow, by shipping features on the new branch as soon as you could. Because what happened was we weren't migrating all the code. We were migrating only what was necessary. We then made it testable. Remember, the old code wasn't testable. So do you know what here? Your mileage may vary. My experience is if you take an untestable code base and you offshore it to a company that doesn't know your domain, and they use AI to migrate it, it doesn't come back testable, right? It comes back nasty. And so what was going to happen was, again, I get the idea, but the outsource company was going to send back the AI code, and then the engineers onshore were going to test it anyway. And so that was going to be pretty expensive. And then, of course, all the opportunity costs that were lost because the product wasn't able to do things. And so again, if you find yourself in this situation, what I want to stress for you is don't do anything and just kind of deal with it, or stop delivering and just refactor. I think those are both the wrong idea. Like economically speaking, financially speaking, they're both a bad idea. The question then becomes, what's the appropriate strategy? The techniques I was wanting to show you is that's how you find the strategy, that's how you execute the strategy, that's how you deliver the strategy. So the kind of results from that last team I was mentioning with you, grew from 1 team to 2 team to 14 teams. Now, it says here, 14 teams, this is not a joke. Prior to the modernization stuff, 14 teams working on the code base, on average, 15 minutes to an hour of active development in a week, right? Now, what could they possibly be doing in the rest of the time? Well, there's a lot of meetings, right? They were also spending an inordinate amount of time debugging. Is this my problem or your problem or your problem or your problem? I don't know, but it's a bug somewhere. How did it get there? I don't know. They spent a lot of time trying to figure out the tooling to get things to deploy. If the teams I was working with had never heard of EJBs, let alone knew how to compile them, right? So that was scary, right? And so we went from this space where there was 14 teams that were barely doing anything to a year later, we only needed 4 teams. It's crazy, right? Now I'm not here to say fire teams. That's not the intent of the conversation. What's interesting is that because of you call it the tech neglect or tech debt, or call it the disconnect between the architecture and the product, because of how these things had grown so nastily, they kept on adding teams to solve a problem that wasn't a team's problem. Once it was cleaner, separated concerns, more testable, kind of less of a code base, they didn't need 14 teams, they only needed 4 teams. I'll tell you this, no full-time employees were fired, but some contractors, of course, were no longer necessary. So, I guess a win for the organization, not a win for the contracting company. Teams are delivering daily, right? So kind of, it didn't happen overnight, but those small, boring changes, once you get good at those, then it becomes the norm. And then it's like, this is so boring, why don't we just get it out of the way? This is so boring, let's just get it out of the way. Do that over and over, and operations doesn't get scared, and stuff doesn't go down, and people are happy. The last thing I'd mention for you there, over and over again, we would have these huge methods go down significantly. 900-line methods come down to 50. 50 might even sound pretty high. I wasn't going for perfection, right? I was just going for simpler and better, and we can kind of reason around it. The teams were continuously speeding up, right? So all good stuff. And of course, production was never impacted. So for me, that was a pretty good deal, right? 14 teams, less teams. I can tell you this, the teams are a lot happier, right? It's a lot cooler working in non-EJBs and working with more modern stacks and kind of stuff that you control, and not guessing what might happen than it is working with legacy code bases and not knowing how to compile it, right? So the teams are a lot happier. But again, just an overall good group. That was the most recent kind of organization that I was doing this modernization stuff with. I gave you that story at the beginning from CME where I did it horribly. If I had to tell you why was CME so horrible for the modernization, they were horrible for other reasons. But why was the modernization so bad at CME? We tried to do everything at once. Like we literally tried to do the Big Bang approach. We literally we left production running for 6 months and just said it'll be okay in 6 months. And it turns out 6 months later it wasn't okay, and people were not happy. People were really not happy. Um, so it kind of lessons learned, right? Don't don't shut it all down and just promise it's gonna be better in the future. All the stuff I mentioned to you around finding the seams and aligning your products, it's all look in working small bits. You can do it today. All the techniques work together to complement each other. That's what I got. What questions do you all have? I'm assuming I won't be blinded by you. Yeah, question up front. I did mention the Mikado method. Who here's no? It's the question from the gentleman in the front was what is the Mikado method? Anybody using the Mikado method or read the Mikado method? Come on. The authors are Scandinavian. I don't want to say Swedish because I don't know how that plays here. The Mikado method, I'm going to do it a disservice by explaining it this way. The Mikado method is really about you have something you want to refactor or something you want to change, and so you make the most obvious change that you think would work, kind of jam it in, and then you literally use the exception handler to find out what caused that to break, and then you move to like where the exception handler, you revert and you move up the stack until you can kind of find a place where you can safely introduce a change. It's almost like creating a decision tree based upon kind of like putting in fast bad decisions. And so it helps you kind of find the safest spot to inject a change. Again, I did it a horrible disservice, so read the book. All right. Anything else? Up there in the back. I cannot hear you. You have a lot of technical debt? Yeah. How do you prioritize technical debt? So I didn't hear the second part, but I'm gonna go with the question being, how did you prioritize technical debt? All right, cool. For this organization, we did it where it was the safest to do it at, right? So like, where could we actually make a change that was safe to get it kind of out of our hands and not kind of live around for a while? I think that's what happens like a lot of modernization attempts, is that there's so much debt that we try fixing a lot of it that we then have to go strip a feature, and it kind of gets put on hold, and now we got to kind of figure out where to do it at, and so we don't get time to ever finish it. So we took the technique of what can we get out fastest? Like, where is it the safest to start modernizing at? That worked really well for that team. With a group at Target, so the retailer in the United States, I was working with a team that was modernizing their point of sale system, so like the cash registers. Now, Target, look, every organization makes bad decisions, right? So Target's idea for 18 years prior to this team inheriting the code base, which was C++, was every year they would outsource to the cheapest vendor, right? So that would be a good idea, and the code base was horrible. And so what we did with that group, with the point of sale system, we got to, like, everybody was complaining about technical debt. We got together for like 2 hours, and everybody just kind of said, here's where I see it, here's where I see it. Like, we just kind of listed a bunch of ideas. Then we had an agreement with the group that was, as you work on this feature, if it's on this list, we fix it right now. And so it was kind of like, as it came up, fix this, as it came up, fix this. And so like that technique worked for that group. So, your mileage may vary, but those are two techniques that I've seen that have worked pretty well.
What about the event?
Yeah, so I saw that with new features,
Yeah.
you introduced local databases. I did not get that point. How will these databases work with the central database? you ever get rid of the mainframe?
So the first question was, how did the secondary databases communicate with the first database? Yeah, and the second question was, did we ever get rid of the mainframe? Okay, so for the first question, as teams started kind of creating their own databases, now, I'm not here to say do microservices or anything like that. Like, for me, it was about modularity, and so those all things, while teams had their own databases, we could have went to a common database, just as long as everybody wasn't reading and writing, because that's where problems start to arise. What we did in the interim, the mainframe was still the back end. And so we had localized databases for teams that would still call the mainframe to propagate data outwards. So like we had a local storage that would then propagate outwards. So that's kind of how that worked out. The second question was, did we ever get off the mainframe? We did not for the first modernization effort. The next modernization, I shouldn't say the next modernization effort. The first thing was WebLogic, right? Get off of WebLogic while we kind of do these things. Then the focus became the mainframe. So that's what we're working on now. That is incredibly gnarly because there is years and years of logic inside the mainframe that people don't even know how it works. And so that is even more scary. But we're going to do a similar technique where it's going to be parallels and then kind of like propagate stuff out and see what happens. Yeah.
That will be on the agenda for next year or maybe after that?
We're starting right now. Yeah. I'll tell you about how it goes next year. There you go.
Yeah, was a question about the Mikado strategy that you were using. Kind of interested in knowing what kind of methodology did you use? I mean, did you put it out as features? Did you went into Kanban? Did you went into a Scrum backlog? How did you move forward with that?
With the Mikado, there's a question on Mikado, and then we're kind of the methodology.
Yes, because you kind of put out each component that you were working with.
Yeah.
But how did you actually put it into development and later on into production? What kind of methodology did you use?
So kind of methodology we use. So the Mikado method, just for kind of clarity, is really just kind of like almost like inside the story as we were trying to do things. It was kind of so like it was more of a technique of exception, kind of move up a stack, exception, move up a stack. So it was really kind of iterating in the development side until we were at a high enough point to introduce a change that we could then ship. So we weren't shipping broken things. In particular, with the question around the methodology we used. This organization was a big safe shop, jokes aside, and they were also using kind of 2-week sprints and those types of things. What we would do, we would talk about for the next 2 weeks, what did we want to learn, kind of like where is that production we wanted to get out, but we would never kind of go beyond any more details than that. And then actually we just did team ensemble, kind of however you want to work at it, because we all didn't know. And so we just kind of worked on the smallest thing over and over as a team, kind of learning as we went, and then building up. And so like it was kind of like safe at an organizational level, Scrum at kind of the team level, or at the reporting outwards level. But inside the team, it was pretty much Kanban and just kind of ensembling. And that worked the best because we just didn't know we didn't know. Yeah. Good question, man. Please.
How do you know which new architecture to jump to so you not end up in more technical debt once you're done?
How do you know which new architecture to move to so you don't end up in the same results? You go with whatever's most popular? Is that, is that the correct? It's a beautiful question. I would tell you that we don't know until we do know, right? And so what we were trying to do by using domain-driven design was kind of find good boundaries and then allow teams to kind of be kind of within kind of context, be appropriate for what they wanted to achieve. But like what we were doing over the course of the year was, when we started off with that first model of teams, it was based upon just a couple scenarios, like the most common scenarios. And then what would happen is we would say, like, if the scenario changes, does it change the boundaries? Does it change the teams? Does it change the decisions we made around the architecture? So we kept on coming back to the models. This morning I was in a great talk by, I want to say Ian, where he was talking about responsibility-driven design and doing like CRC stuff. Like that's the kind of, like we were constantly modeling and saying what if, and so we tried to make the change horizon for any architecture decisions so low that we could pivot easy. And so it sounds kind of hand-wavy and fluffy, but I think that's what we tried to adhere to, like the idea that we're going to be more wrong than right. And so like don't create 25 interfaces before you have 2 implementations, right? Like just kind of common sense. And so we tried to, again, don't be smarter today than we need to be. It was a lot of that stuff over and over again. We knew where we wanted to go, but let's not be too far in advance. Yeah. Anything else? All right, I'll be here today and tomorrow if you want to jam. Oh, I almost forgot, but I didn't. The sticky note card things for the feedback, yeah? Yeah, please do that. Yeah. Thank you.